My name's Eden Badisher, Principal Research Scientist with Education Development Center. Today, I am going to take you through some underlying principles as well as conventions for the production of system maps. This is really to help us level set for the meeting on July 18th next week for the Includes Hub working session. Some of us will be brand new, haven't been to the last one. Some of us may have been to the May session where we learned about these conventions. And so this is just an opportunity for those who weren't there to see these ideas, wrestle with them, think about them a little bit, and then we'll use them at our next session, which is July 18th. So the process that we talked about is called community-based system dynamics, or CBSD for short, and it's an approach that helps us develop maps of systems in question. Okay? And the question that we are wrestling with is the systemic exclusion by STEM of populations who are historically marginalized in the United States. So important foundational idea is, of course, when we're dealing with systems, is the idea that very little of a system is actually visible to the naked eye, as it were. Just like in an iceberg, we only see the tip of the iceberg. The majority of things that contribute to system behavior are actually not visible until somehow they're made visible. And that's part of what we are actually going to be doing, is making visible a lot of this underlying structure, these mental models, and so on. So it's really important to keep in mind that any event we see, any outcome we see, is really just, a very small tip of what is in fact taking place. So with that idea is certainly the idea that linear thinking doesn't really work well anymore when we're talking about systems, because systems take on a life of their own and they're really self-perpetuating, right? So this idea that if I take an action, there'll be a predictable effect, and we can use cause and effect to impact systems, really gets us into trouble, right? And it's often why for so long we haven't been able to change systems, is because we keep applying a linear model to something that doesn't work in a linear way, right? So what we really need to understand is, in fact, that there is feedback behavior of a system. It's this feedback mechanism that enables a system to take on a life of its own, right? And so here, the idea is not that there's an action and an effect, although there may be, right? But that this effect itself actually has effects, right? That might reinforce the action. And in addition to that, the action, which has one effect that we think may have other effects as well, and those other effects will feed into the system, right? So what we want to do is find ways to get at all the different feedbacks that are happening in a system. What is happening that allows it to perpetuate itself, right? If it's a system that's working really well, we want to understand those feedback mechanisms so as things evolve, we don't lose them, right? Or if it's a system that is really working counter to what is important to us and what we value, we want to understand that feedback so we can change the feedback, right? And what the pictures that you're seeing are three, just examples of what it means to do these kind of system mapping models. A critical piece to understand when we're talking about systems is that complexity is actually part of the problem itself, right? If we want to simplify, we're actually eliminating part of the system, right? So if we want to have and work with a system, we want to understand that system itself because they're evolving all the time, right? Again, once they are active, they have a life of their own, right? And so they're moving. And if we don't understand the feedback and how they're moving, we are at a disadvantage. Additionally, there's so many stakeholders in any system. Think about 18 head chefs all trying to make carrot cake. And they have different recipes, they have different goals. Somebody might prioritize moistness. Somebody wants all these carrot elements in it. Somebody else wants cinnamon. Somebody else is allergic to nuts, right? So they'll have different goals, different recipes, and they're competing with each other. But we got to make one carrot cake. Okay. So if we ignore the different stakeholders, we have problems out of the gate. Right? Another thing about systems, especially because they have a life of their own, right? There is significant time lags between when we start something that has system change and when the change might actually become visible at the top, right, of one of those icebergs. So we have to understand the time structure of a system in order to be able to think strategically about what it will mean to change that system. And as I mentioned this briefly before, is this idea that when we take an action in a system because of something we're trying to do, remember there's lots of other feedbacks happening. And as such, there's going to be unintended consequences, right? We want to be able to predict what those unintended consequences are, because if they're bad, we want to try to minimize those. Or if they're good, ooh, right? How can that help us? Okay. Wrong direction. So the idea of complexity is is fundamental when we're dealing with systems. So there's three classic approaches, right? I'm going to act, I'm going to throw stuff on the wall, I'm going to see what sticks. I'm never going to understand the whole thing, so let's just try something. Right? Sometimes this is awesome. It can work, right? But very often it doesn't, or it makes things worse, or we get frustrated, right? So we can do it, but we have no idea what's going to happen, right? We could also simplify a problem. We do this all the time in STEM, particularly things like physics and math, anything where we model. We love to simplify. In fact, the maps that we'll draw are in reality simplifications of complexity, right? The idea here is we can't take on and manage this whole thing. So let's simplify and let's just look at these two relationships. Well, in theory, that's great. But in reality, those other things are going to have an impact on what I'm trying to change. So if I did something and it doesn't cause a change, is that because my idea was bad? Not necessarily, right? Or if it causes great change, is that because my idea was good? Yeah, not necessarily, right? Um, because it could be related to how they're interacting with all these feedbacks. Okay? So the last element, which is of course what we propose is that we learn how systems operate. We learn how to deal with and engage with the uncertainty, but also by learning how systems operate, we've actually removed some of the uncertainty. We can predict, we can have ideas about what will happen if I do this thing over here. Because how many things is this one thing connected to? And I can begin to predict the different paths my actions will impact, right? So community-based system dynamics is a participatory approach to involving communities, stakeholders to build a model. Remember, it is still a model. We inevitably are going to lose complexity because we can't have the entire world in our work, right? But we engage in group model building to understand and change systems using this idea of feedback, right? This idea that systems take a life of their own. And so it's not just operating on one thing. We have to think of the system as a dynamic entity, right? So, and the focus is on building capacity to understand these models, their uses and their limitations. Okay? And so there are important assumptions in CBSD. The first is, of course, inclusivity, right? We want to disrupt the idea that some people are better suited to solving problems than others. This is important because of that, like, all those cooks in the kitchen to make the carrot cake, right? If we don't have the stakeholders all the stakeholders, we're never going to have an outcome that responds to the needs of the different groups. Okay? Additionally, experience is expertise. Again, we're trying to disrupt the notion that researchers would solve problems or politicians would solve problems. Those are important perspectives, right? And those are important experiences, but they aren't more important than the experience of people living in the systems, right? If you don't have the experiences of the stakeholders living the systems, there is going to be fundamental things missing. There just will be. And we have to start to understand that that experience is as important, if not more so, than some of these other more traditional ideas of who helps, tackle problems, right? A researcher is no longer a privileged perspective, and that is good. It is one of many, right? The other idea here is that CBSD is asset focused, meaning you actually, as you're watching this, you're like, oh my God, how am I going to do this? I'm not trained in CBSD. That's okay, right? Its central idea is both that you have and everybody has the capacity to engage together to understand their system, right? Yes, we'll go over some conventions, right? We're going to, we'll talk about things, but that doesn't have anything to do with your ability to interrupt or make sense of or reform your system, right? It's a tool. Right? So that's really important. It's asset focused. We are all capable of changing the systems in which we operate. This is a good example of a system. So STEM Ops, the Includes Alliance. I was the first PI, the founding PI on STEM opportunities in prison settings. And this was a loop that we created of the overarching school to prison to reentry pipeline. We actually integrated 4 different streams of research, right, with communities to get this. Okay. And so you'll see that there's words on the screen. There's these semicircles with arrows and either the letter R or the letter B. We'll talk a little bit about those. You'll see colors. This one has two colors, but if you're colorblind, maybe you don't see that, right? So in this one, we have two key elements in addition to two colors. While you can't see it, but you'll see it in a moment, is that there's also plus and negative signs, right? So these are all common elements of what we call a causal loop diagram, and it's showing all the feedback in a system and how the system is perpetuating itself. It's one model, right? So you might be thinking, why on earth we'd want to do this? Well, first of all, the idea of working together on this and learning from each other about your different experiences and how that shapes, just the act of doing this transforms your understanding with and your relationship with that system. Right? So that's great. And with each other and the different stakeholders. That alone is phenomenal. But additionally, we now have a tool that can help us start to think about how do we strategically and systematically change a system, right? We have variables on which we can act. There are feedback loops. Those are those things, those R's and B's, feedback loops that we can act on. There are rules that govern a system, right? Structures, remember the structures in the iceberg, right? Rules that we can act on, right? So our prison system, because I'm coming from STEM ops, we have a very carrot and stick approach, right? In the United States, that is a rule that governs our system, right? Goals of what is the goal of a system, right? In STEM ops, a goal of the system as it is to quote unquote keep bad people off the street, right? But I think, as we know, it doesn't really effectively, you know, that is not what actually ends up happening in reality. And when we think about mental models, if we want to change mental models, when we're looking at our criminal justice system, not all people are inherently valuable. That is an underlying mental model of the system. And that's why we have this keep bad people off the street. That's why we have this carrot and stick approach and so on. But now we have all these ways that we can begin to think about changing a system. So we are empowered as stakeholders in the system with this map. So I am going to quickly run through an example with everybody so that you can get the primer, right? Get those conventions that we're going to use on July 18th. Coffee. And this is a good example because most people can connect with it. You may not be a coffee drinker. I happen to be a tea drinker. Maybe it is something else that gets your juices flowing in the morning, right? Running, I don't know. I do not run, just for the record. I think it's awful. Anyway, so a typical, very, very linear framing of the problem is if I drink a lot of coffee, I'm not going to sleep. Certainly not going to sleep well. And yes, caffeine has a half-life of like 12 hours, so it does stay in your system a long time. So let's think about this, though, from a feedback perspective, because the situation is quite a bit more complicated than that. For example, there's lots of reasons I might drink coffee, or I might drink more coffee, right? So, but let's start with these three. I have a required level of coffee to function. In my case, I make one very big pot of tea in the morning. By 10 a.m., I don't drink any more caffeine. I drink that one pot of tea that probably is like 45 ounces of tea. I don't know. Anyway, it's a lot. But um, um, when I wake up in the morning, I want my tea. I have a tea shortage. So there's a coffee shortage. I do not have what I need to function appropriately. Okay. So simple solution is to ingest your coffee, tea in my case, right? And if you ingest your coffee, you don't have the shortage anymore. So this is where in that map I showed you earlier, we use two colors for those lines, and we use plus and negative. In this case, you'll just see plus and negative signs. All the lines will be the same color. Okay. So we talk about relationships that have positive polarity or negative polarity. And the way to distinguish those, the thumbs become the greatest tool ever. If an increase in one thing leads to an increase in the other thing, that is positive polarity. If a decrease in one thing leads to a decrease in the other, that is also positive polarity. And you might be like, well, that's your fingers or your thumbs are pointing down. How is that positive? It's the idea that either way, both thumbs are pointing in the same direction, right? That is positive polarity. As my required level of coffee to function goes up, my shortage in the morning is going to go up. On the flip side, when an increase in one leads to a decrease in the other, or vice versa, that's when we have negative polarity. So as the amount of coffee I ingest goes up, or caffeine as it were, my coffee shortage goes down, right? So see, my thumbs are going in opposite directions, right? So think of the negative as opposite and positive as same. So now let's build out this model. To have ingested coffee, I need to go through the act of drinking coffee. So let's add drinking coffee. The more of a coffee shortage I have, the more coffee I am going to drink, which means I have ingested more coffee. And the impact of that is, however, that now my coffee shortage goes down, right? So at the beginning of this loop, we had an increase, right? I have a high coffee shortage, so I'm going to I'm going to drink coffee. Now it leads to a decrease in the end. We call this a balancing feedback loop, right? And this is where an initial increase ultimately leads to a decrease or vice versa. And what you actually find in this case is as you continue to follow this loop around, you have a up and down type goal-seeking oscillating behavior. So first, big coffee shortage. I drink coffee, I ingest coffee, little coffee shortage. So I drink less, I ingest less. So now my coffee shortage is back up, right? So you have that wavering activity. I did, however, mention that, it's not just my required level of coffee to function in the morning that might impact why I drink coffee. Maybe I drink it because I love the taste, which is going to cause me to want to drink more. I'm at work, got a big presentation. I need an additional cup of coffee to boost myself, right? That's a very real one for all of us. Because I need more productivity, my coffee shortage has now gone up, right? So I'm going to drink more coffee. I'm going to ingest more coffee so that my coffee shortage goes down. That is great. Solve problem, but not, because if I drink more coffee than normal and have more caffeine in my system, now my sleep is going to be impacted, right? So the more coffee I ingest, the greater the impact on my sleep, which is going to translate into an increase in lost hours of sleep, then more lost hours than the usual, which lo and behold means since I'm going to be more tired the next day, I need more coffee in the morning than I otherwise would have, because now I don't have just my normal coffee shortage. I don't perhaps just want to get increased productivity. Now I have to overcome tiredness, right? So now we have a cycle that is going to keep worsening potentially. So the first thing to know, though, is we have this little red double line in there. What the implication of that is that this change takes time. If you do this one day and you lose one night's sleep and then you go back to normal, it's not going to change, right? Much, But if this becomes a continual habit, I'm always needing to increase my productivity because I'm always tired, blah, blah, blah. Over time, my coffee shortage will fundamentally change because my required level of coffee to function is going to fundamentally go up, right? So this is one of those time lags we talked about, right? The other thing to note here is this has given us a reinforcing feedback loop. So whereas the balancing loop had an initial increase, ultimately led to a decrease, now we have an early increase leads to more increases, right? So, or it could be the other way around, by the way, a decrease leads to a decrease. We often see exponential growth and decay, right? Here, it's important to recognize these are the things we often call vicious cycles or virtuous cycles. If a little change leads to more change, and that's a good thing, it's a virtuous cycle. If a little change leads to more change, but the consequences are bad, that's a vicious cycle. Coming from STEM ops, I can tell you that every one of the reinforcing cycles we have modeled in the school to prison pipeline, in the reentry pipeline, every one of them is vicious. None of them work productively. And that's part of what we were trying to change. So a reinforcing cycle, again, keep in mind, just always think that's the vicious or the virtuous. And if you see a reinforcing cycle that's vicious, that's also a really good hint that might be vicious now, but the flip can be, did I say that right? No, the switch can be flipped. A vicious cycle can become a virtuous one. So anyway, that is the little primer that you need for coming into our session on July 18th, I think, again, is the date. So I will hope to see you there. And come and be ready to have some fun thinking about feedback in our system of STEM's exclusion of underrepresented populations in the United States. Thank you. I hope you have a wonderful, I don't know, is it a day? Is it a week? I don't know what it is for you, but I hope to see you soon. Take care.